Okay, as we continue, 6.02b, perpendicular bisectors. Another word for this perpendicular bisector might be called a right, meaning a right angle, or perpendicular, right angle. Bisector means it's going to cut in two. So a perpendicular bisector is a perpendicular line draw through the midpoint of a side. The point where three perpendicular bisectors of a triangle meet is called the circumcenter. This point is equidistant from all three of the vertices. So, if we were to draw the perpendicular bisector of AC, again, we never trust our measuring tools, we trust the numbers. But we're going to use a measuring tool here. These are the exact same two triangles that we used for medians. Yep, still 5 centimeters, so 2.5 is halfway. I draw my nice communication to show that it's halfway between A and C. It's cut it in two, bisected it in two even parts. Instead of, like our median, it going through B, now it's going to cut and go at 90 degrees. So I'm going to use some nice knowledge that these little marks are 90 degrees to the drawing edge. So I'm going to do that. And to tell myself that it went 90, or to inform you so you know it's 90, I'm putting in 90 degrees in there. Now this line goes on forever. It does cross B and C at that point. And we could determine that length like we did for medians, but there's a little bit more involved, and we're going to save that for next lesson. So there it is. We do the same thing here for Q and R. Again, crosses at 90. If I want to look at all the rest, and let's see how they go. If I look at Q and P, it's hard because I can't get my eye right over through the camera. Again at 90 degrees. It's outside the triangle, and that's okay. I'm going to extend this even further. Look at P and R. Crosses at 90. Look at that. Super. The circumcenter. There it is. This line is the same distance, or this point, circumcenter is the same distance from P as it is to Q as it is to R. If we were in class, I'd show you something nice on the board for that, but let's not worry and confuse you too much. So, once again, here we are. We have A, B, and C. 3 points. Let's see if I can keep it consistent with the other lesson. Vertex A, vertex B, vertex C. Make a triangle. We want to determine the equation, the perpendicular bisector through AB, which also means the perpendicular bisector. We wouldn't even say from vertex C because it never goes through C. So let's put those points. negative 2, 2. There's A. There's B. And there's C. Once again, we'll use our straight edge drawing tool and connect the dots. Now, if we need a perpendicular bisector through side AB, we need to find the midpoint and then draw a 90-degree line through that midpoint. So step 1, we still need midpoint of AB. So we continue our midpoints. Take what we know, put it in the formula. And we math. So the midpoint is 3, 3. 1, 2, 3, 1, 2. Whoa, look at that. Now, because the graph is here, this is just going to support our math. But once again, if we know this slope, if we need it to cross at 90, we're going to take a perpendicular slope. So our second step is we need the slope of AB, and then we're going to take that slope, and we're going to take the negative reciprocal slope and use that to go from here. So, slope of AB. Y2 minus Y1 over X2 minus X1. And we continue to math. 8 minus negative 2 is 8 plus 2. We reduce that to 1/5. So that is the slope, the actual slope of A to B. We need the negative reciprocal. We actually want negative 5 over 1, which is really just negative 5. We have the graph. We could plot those points. So negative 5, the slope of negative 5 means down 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. Let's go the opposite way. Instead of going down 5, I'm going to go up 5. Instead of going to the right 1, I'm going to the left 1. And it continues and it goes on, and it's out of my chart, my graph. But there is the actual perpendicular bisector for AB. I have that slope I just found, negative 5. I've also got a point. There's a point on the line. So now my third step, sub what I know. I'm going to use slope and the midpoint of AB to find my y-intercept. So again, I'm going to sub that into y equals mx plus b. Got a point, 3, 3. I got a slope, negative 5. And I'm going to math. I got a slope, got a y-intercept, I've got my line. So therefore the equation of the perpendicular bisector of AB or the right bisector of AB, y equals negative 5x plus 18. Boom. I want you to think, if we had another example, another question, it would ask us how we find the length of that line, which means we would need to find that point. How would you go about finding that point? Because that's coming up. If we were in class, I'd ask you to discuss with the person across from you, your current lifelong math partner, and see what you can come up with. You have all the tools. If you would ask yourself this question, you should be able to connect the dots. Alright, give those lines a try.